What's going on, friends? List comprehension is a fast and elegant way to create a new list based on an existing iterable. This is a powerful functionality provided by Python that allows you to write clean code with just a single line of code. Set and dictionary comprehensions are the other forms of comprehensions. In this lesson, you will learn how to effectively write code with comprehensions and when not to use them. Let's get started. Suppose you have a list of numbers and you want to get the squares of the numbers in the list. You would probably want to use a for loop to solve it. First, you initialize an empty list to store the squares. Let's call it result. Result equals an empty list. Next is to use a for loop to iterate over the original numbers. For num in numbers, this inner part is the loop body. It runs for each number in the numbers. Now let's add the square of each number to result. Result dot append num times num. For each number in numbers, we add the square to result by using the append method on a list. Let's print out the result. Print result. Now let's execute the program to see the output. We now have a new list containing the square of each number. This solution involves 3 steps. The first step is to initialize a list. The second involves looping. And finally, the third step is the append operation. We can achieve the same result in just one line of code when list comprehension is used. This is the syntax of list comprehension. For each member in the iterable, the specified expression should be executed and the result should be added to the list. Let's revisit the previous example. Result equals, we bring in the square brackets for num in numbers. This part of the code on the left hand side should be executed num times nums. For num in numbers, this part of the code will be executed and the result will be added to the list. Let's run the program to see the output. We have the same result. This card on the right hand side shows the equivalent when the map function is used. For more information about the map function, be sure to check the top 30 functions you need to know. List comprehension supports adding a conditional logic. Here is the syntax. For each member in the iterable, the member is considered only if this condition is true. Let's say we have a list of numbers and we need to filter numbers that are greater than 4. Let's make use of list comprehension. Result equals for num in numbers. Num should be returned, which is the number. Now let's put a conditional check if num is greater than 4. For num in numbers, this part of the code should be added to the new list, but we put a condition here. If num is greater than 4, that is, the number will only be considered if this condition is true. Results. Let's execute the program. Fantastic. We now have a new list containing numbers that are greater than 4. Another version of the conditional statement is when you place the condition near the beginning. This is particularly useful when you want to use a ternary operator for each member in the iterable. If the condition is true, this expression should be considered, else this should be considered. Result equals square brackets for num in numbers. If num is greater than 2, this part of the code should be considered, else this should be considered no. This means if the number is greater than 2, yes will be put into the list. If not, no would be considered. Let's print out the result. Print result. Let's execute the program. Great. We have the result. A set comprehension is almost the same as a list comprehension. The difference is that set comprehensions make sure the output contains no duplicates. Let's turn the previous example into a set comprehension. We just need to use curly braces instead of brackets for num in numbers. This part of the code should be put in the new list num. Let's execute the program. 4 is repeated twice in the initial list, but in the final output it appears once. Dictionary comprehensions are similar. We only need to add the key. For instance, we can make this a dictionary comprehension. Now let's execute the program. Great. Let's further check the type of the result. Type. Now let's execute the program. This shows it is a dictionary. While list comprehensions can allow you to write elegant code, they may not be the right choice for all circumstances. List comprehension loads the entire list into memory. Therefore, it is suitable when working with small or medium-sized lists. However, if you are dealing with millions or billions of data, using a generator is recommended. Otherwise, the computer might crash due to the excessive memory usage. For instance, this code is using list comprehension to calculate the squares of all the numbers from 0 to 10. We can turn this to a generator by using parentheses. This is no longer a list comprehension. Generators use lazy evaluation, which means they produce values on the fly as you iterate over them. This can significantly reduce memory usage because it doesn't generate the entire sequence at once. Let's print out the squares print. This shows squares is a generator object. Since generators are iterators, you can use a for loop on them to retrieve the items, or you use the next function to retrieve the next element in the iterator. Let's make use of the next function. Next. Now let's execute the program. It works. Subscribe, like, and comment. Thanks.